theoretical probability, the chance of stuff happening is a select situation, but this does come up, and you'll see it at different times. And it specifically deals with 2 dice. What is the probability of rolling 2 dice and having these numbers show up? So first of all, we have to understand, we're going to imagine that the dice are 2 different. So what we want to do is start writing out pairs. And this is one of those things, you write it out once, you don't have to ever write it again, you just look it up, that way you have it. But you start with, what's the lowest pairing that your dice can be? Hopefully you're saying 1, 1. Now I build from there, and again, let's say the black one was 1 and the green one was 1. So let's build my pattern from there. Let's keep the black 1 every time. Well, what else can the green be? 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay? Now, what I can also do is work to build my chart. So let's say the black one now becomes a 2. Well, what can the green one be? Let's say the black one stays at 2 the whole time. I could have a 1, a 2, 3, 4, 5, and a 6. Hopefully I see how your chart is starting to develop. I could have 3, 1, 4, 1, 5, 1, 6, 1. And this would be 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Now realize all of these would get filled in. 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. If you look down your diagonal, you should have your common pairs, 3, 3, 4, 4, 5, 5, and 6, 6. But all of these would be filled in. I just want to speed this up a little bit if I can. Now, one of the main obstacles to begin with is when you say to somebody, roll 2 dice, how many different ways can it land? Too many times kids will say 12 because they think 6 on one, 6 on the other, 6 and 6 give me 12. That's not true. If you start looking at the scope of my table, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 times 6, and we know a little bit in probability with compound probability, I take one probability times the other, 6 times 6, and gives me 36 total outcomes. So step 1 is just understanding that you have 36. Now from here, questions get asked. What's the probability of an even number on the first die and a 5 on the second die? So what we have to do is make our probability. Well, I know it's out of 36. Just want to make sure I'm still in the frame here. So now what I have to do is look at all the different pairings that have an even as the first number and a 5 as the second number. It helps when you have your chart. If you don't, you just try to list out all the examples you can think of. So let's take a look. I need a 5 for the second one, so I'm going to look at this column. 1, 5, no, it needs to be even in a 5. 2, 5, 2, 5 works. 3, 5, no. 4, 5 works. 4, 5 works, and 6, 5. So that's out of 36 examples, the only 3 that work are this one, and this one. So my chance or my probability becomes 3 out of 36, which reduces to 1 out of 12. And I could get a calculator if I wanted the percentage and do numerator divided by denominator and get my percentage. Let's try a different one. Probability of number smaller than 4. And let's not get too crazy here. And a 1. Probability of the first number, the first die must be smaller than 4, the second one must be a 1. So I'm going to start with the easier one, which is a 1. So I'm looking at the first column. Something less than 4. This is not less than 4, this is equal to 4, so I can't pick him. 3, 1, 2, 1, 1, 1. Again, this would be 3 out of 36. This is just by chance of the ones I'm picking that work. They're not all 3 out of 36. Same reduces to 1 over 12. Last one. Probability. What if it's probability that I get doubles? So what I would say is, again, out of 36, how many different pairings give me doubles? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. 1, 2, 3, 4, 5, 6. 6 out of 36, or 1 out of every 6 times I roll, I should get doubles. Doesn't seem that way, but in theory I should. Just like rolling a regular die is 1 out of 6, trying to roll doubles should be 1 out of 6. So this is 2 dice probability. Good luck.